Hi everyone, I'm really excited to explore Stable Diffusion with novel Rhino Grasshopper workflows. And I'm going to showcase another example in this video for you where I have generated a parametric model that could be fed in as an input for image generation using Stable Diffusion. So I'll first show you what I have done in Grasshopper, but basically I have generated a pretty standard parametric form. Let's call this as a tower shape. So what I'm doing is I basically generate planes in the vertical direction. So let me actually walk you through what this code does. So let's actually disable this portion at the end. So I start with planes as a series of planes, and you can actually control the spacing of these planes as well as the number of planes. So I'm keeping it as at 30. And then I generated a rotation property for this. So you can use Graph for rotation control, but I made it just a simple twisting shape. And I control the amount of twisting with this parameter here, and placed an ellipsoid on each of these planes using two different radius functions. And then you can actually create more a twisting shape or like a smoother shape, controlling the amount of rotation here. And the next phase, I basically divided the ellipses into points. So you can control the number of points here. So let's keep it at 20. Then this flip matrix basically creates an array in the vertical direction that you can interpolate so that we get this sort of distribution of lines. And the final process is basically generating pipes to kind of model facade elements. You can make them thicker or thinner. Let's make them actually a little bit thinner here. And I generated a surface as blue. So the behavior is pretty interesting. So you can actually control the amount of twisting with this rotation parameter here, and you can control the pipe radius here as well as the number of louvers. So I'm going to increase the louver count here by dividing the ellipse into more points. And the next phase is actually pretty interesting. So you will input this as a conceptual image to Stable Diffusion to get some photorealistic renders. So there are a few ways you can actually play around with this. So one way is to find an angle that you would like to use. For instance, you can play around with the lens length and zoom in to the form like this, or you can look at it from bottom up, like at an angle. And I will just right click and basically save this view in case you lost it. So you can just give it a name. Let's call it our angle. And then you would come here and output this as an image. So in the second step, you will have to choose a directory. So I'll just go to directory, and I've already created one called tower here. And inside the tower folder, once you click on export drawing, what it will do is it will actually use the viewport in Rhino, and it will override this input image img, right? So this will become your input for the Stable Diffusion algorithm. Then you can right click here and choose that as your input. So this is our input image. And the next phase is basically you define some prompts. Like I defined here, a parametric tower, Zahadid style, facade, realistic render, blue sky, perspective. And I added some negative prompts. Basically, I wanted to replace white or some other colors, or maybe you don't want to see any of these colors being used. And then you can play around with this inference guidance and strength values. And I have written some information here. So inference is basically the number of routines the Stable Diffusion algorithm runs. Guidance is how much you want the prompt to have control over this, and strength basically controls your input image, right? It's like how this input image has an effect in the final result. So it's basically going to run some routines over your input, and we have a remote server here that is running image-to-image workflow. So when I trigger here, it will send a request and generate an image, and the output will be visualized here. So you can see the conceptual lower direction basically becomes a direct input for the image generation, and you also have some randomness to this too. So we don't, for instance, get more detailing, but it will be interesting if you add more details to this and see the end result. So let's try to generate a few more variations. So I'm going to keep rotation a bit more less, more vertical, and maybe we make the pipes a bit more thicker and see what we get at the end. So I'm going to decrease the number of count. So this is basically creating another type of angle, and you can look at it from another viewport, but basically as you replicate this process, all these routines will be updated, right? So you just press these buttons, and immediately we are actually working with parametric modeling tools as well as artificial intelligence tools, right? So it's creating a lot of novel workflows that we can investigate and we can customize with the prompts. So it is something that you can try to generate conceptual images, but the inputs don't have to be detailed models. You can keep them as simple as possible. Use a few elements to control the colors in the input image, and then basically engineer the output using Stable Diffusion with the prompt. So I'm just going to press a few more times to see what other results we can get, but you can see that the lower direction basically becomes an input for our conceptual render. And you can also increase the image influence here and the prompt guidance values, see if we will get another result. And all of these images will be stored as an archived folder, so you can actually directly work with this sort of workflow and keep track of your generated results. So there we go. I'm getting basically this becomes pretty much consistent with the images, but having a lot of artifacts like the reflections and other types of sky results as well. So give it a shot and let me know what you think about this type of workflow, integrating Grasshopper tools with Stable Diffusion, and I'll be doing more examples in future videos. So if you want to follow this type of tutorial, subscribe to the channel, and thank you for your support.